Solve systems using tables. Last time we saw that if we have a graph for each equation, where the graphs cross is the solution to our equations. And we know from that assignment before, on parallel, intersecting, or same line, that if they don't cross, they have no solutions. If they are the same line, they have an infinite amount of solutions. Today, we're going to learn the second way of solving a system of equations, this time with tables. And once again, we will be using our Desmos calculator. So let's dive right in and take a look at what we got. You now see a table. A lot of students skip ahead and try and do this manually and create a lot more work for themselves. The table function in our TI-84 Plus graphing calculator in class and also in Desmos is very handy to fill out and copy tables like we have in number 1. Here's what we do. Whatever left equation you have, just type that in first. So I've got y equals x minus 5. And then below that, I have y equals 2x minus 6. And there you go. We have our graphs, but we want to get the table. This is a gear button right there I want you to look at. So stare really hard at your computer and find this mark that I'm pointing to in this arrow. Click that button. When you do, you'll notice some options. Click the table. The table. And you could actually end up doing that for both of these. All right, so at 0, I see that my first table is at -5. My second table is at -6. Then I go to 1, it's at -4 and -4. And then at 2, I see -3 and -2. And then notice it doesn't have 3, but all I have to do is just like go up to my table and type a 3. And it says, oh, that's -2. And here, do the same thing. Type in 3. And it gives me 0. So once I fill out my table, that was super fast. Then I just compare where they cross. 0, -5, 0, -6. 2, -3, 2, -2. But look in the middle. 1, -4 matches 1, -4. So watch how I write this. I write this in as 1, comma, -4. And I could check that. Check it out right in the middle. These bad boys match. It's a little tough to see. But that's kind of cool. It creates a little separate plot for each of these. They cross at that point that it just showed 1, -4. Okay. Number 2, we're going to get rid of these equations and type our new ones. So I've got y equals -x minus 7. And I've got y equals 1/3 x minus 7. Okay, well, I could cheat a little bit and click in the middle, and I'll already know that my answer is going to be 0, comma, -7. So that tells me that each of these points are going to be at -7. But what about the rest? So let's go in and let's see with our graphs. It's a little annoying that it has this error. I don't want that, or that undo button. You have to wait for it. All right, we went from -1 to 2. So -1 is by -6 up here. Oh, man. All right, let's see. They normally want fractions here. Let's see if we type in our whole decimal here. So I just got a bunch of 3s. This is quite annoying. And then 1, I've got -8. This is the only one where we're going to have to do this. And then this one's just going to be a problem. -6.666666666, and then they want a 7 at the end. And then -9. I apologize. This is one of those where if we had our graphing calculator, they would spit all these out as fractions. And instead, let's see if they count them right. Okay, they do. So I apologize. If you know that this is 7 1/3, and you could put that in as a improper fraction, you could do that. But instead, just type exactly what decimals you have, even though it's the super long way of typing it in. It's only on number 2 where that's going to come in. All right, number 3 does not have decimals, but it is quite long. It's a word problem. It says Carlos put, now you're going to have a separate number than me, but similar problem. I've got $20. Carlos put $20 in a savings account at the beginning of the year. At the end of each month, he adds $25 to the account. Anna put $540 in her savings account at the beginning of the year. At the end of each month, she took $40 out of her account. Let X represent the number of months which have passed and Y represent the amount in each savings account. Complete the equation to represent the amount Y in Carlos's savings account. Y equals blank. Similarly, complete the equation to represent the amount in Anna's savings account as the amount Y equals blank. Complete the input-output tables through 8 months. All right, well, in Desmos, let's clear out of these old equations. We're not going to need them. And let's just write our new equations. So Carlos, we know, he starts with a certain amount of money. Mine's 20. So for you, whatever amount you have for yours, type that. Don't put a Q in there like I just did. And then at the end of each month, he adds, so plus, and how much you're plussing. Mine's 25. Again, don't use 25 unless you have 25. Use your numbers. Similarly, I've got that Anna put in $540. So she already got that money, but she's going to take out, so minus 40 each month. Then I could type in Y equals 20 plus 25. Oh, check it out. So because it's each month that she takes it out, put an X on the end of each of these. I'm going to match that here too. So 25X, and I've got Y equals 540 minus 40X. All right, it's a very large graph. We'd have to zoom way out, but that's fine because we're going to go up to our gear button. We're going to turn them into tables. And as that's loading, I know I want from 0 to 8, so I'm just going to go ahead and I'm going to make this from 0 to 8. Oh, I skipped 4. 4, 5, 6, 7, 8. Notice how it keeps adding rows. And then I'm going to do the same thing for this one. Table, start at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then we can just copy. So my first one is Carlos. So we've got 20, 45, 70, 95. Notice it's just increasing 25 each time. It's going to look so beautiful, though, trust me, when you get all these right. And down here, let's go to Anna's. She starts at 540, and each time she loses 40. I'm going to go very carefully to make sure that I don't mistype one of these. 260, and finally 220. All right, and then where do they match? It looks like it's at the very bottom for me. At 8 months, they have $220 left. So at 8 months, 220. If you don't see where they cross, double check your work, and then you could use the graph, zoom out probably, and then you can click up. See, 8, 220 is the point on my graph. That also matches. And look at all those beautiful green check marks. So nice. All right, number 4. 2 submarines were headed toward one another. Uh-oh. One followed the path represented by the equation. Here's another one of those math problems that makes no sense, but whatever. We'll go with it, sure. People are writing submarines with linear equations. Because that happens in the Navy, I'm sure. So I write my 2 equations. And we want to see where they cross. Now, I could zoom in with my graph. I had to zoom way out for that last one. All right, and I can look in these, and ideally, again, TI-84 graphing calculator, you go to the table, you scroll down, you see where they cross, boom, boom, you're done. But with Desmos, since we're away from our classroom right now, let's just click on the point where they touch in the graph, because we know we can do that each time. 5, 31. So it says, solve the system of equations using two input-output tables to determine when the submarine paths cross. The submarine will cross paths after blank minutes, where minutes is x. Let x represent the number of minutes. So basically, what's your x coordinate of your crossing point? Since they cross at 5:31, it is 5 minutes. So just put the x answer where they cross in your graph. Or if you use tables, do the same thing for the table. All right, 5, 6, or 7, we're going to do the same thing. So I've got negative 4x plus 9. And I've got 3x minus 12. 3x minus 12. Okay, zoom out. They cross at 3, negative 3. So the last three, it says we need the ordered pair. And again, I could turn them into tables. I'll show you. You could turn them into tables. The problem, though, is that you're not going to know. If we had our TI-84 plus calculators, it would just show you far greater of a range. But you're not going to know what range to search, which is why, yeah, see, 3, negative 3s. These match. But for the sake of these last problems, just use the graph. Don't worry about the tables. We've done enough table practice already, especially from that long word problem. Just do these last ones by finding where the graphs cross. And these cross at 2, 3. Don't forget the parentheses and the comma. And we're going to just have two last equations to plug in on number 7, and then we'll be done. There are assignments right now when we're potentially away from school that I am very jealous of a time when we were in class able to use the resources, but we're going to just use the best we have right now. And that means using the graphs instead of the tables on each one of these at the end. Okay, 7 problems done. 3 with tables, 4 with graphs. They come by land, they come by sea. We come by tables, we come by graphs. And there you have it. There you have it. Okay. Next time, we'll dive into some substitution. We'll do some elimination. But this graphing calculator is going to be your best friend this whole unit. And I'm glad we have it. Have a wonderful day, and I'll see you next time. Bye-bye.